The Lorentz force is a phenomenon experienced by an electric current which is made up of negatively charged particles or electrons moving through a wire. Shown here as yellow particles, electrons move from negative to positive. However, the convention is to think of electrical current as moving from positive to negative, so that's how we'll show it here using red particles. If it's not moving, a charged particle doesn't create any magnetic field. But when it moves, it generates a little magnetic field around it, shown by these green arrows. Flip the direction of the current, and you flip the direction in which the magnetic field circles around it. The magnetic field produced by the current will interact with another magnetic field, just the way two magnets repel or attract each other. Here's a horseshoe magnet with a north and south pole. The magnetic field always points from north to south, as shown by the blue lines. This wire is arranged in a kind of pendulum, so it can swing back and forth. Let's insert the horseshoe magnet into the setup and see what happens when electricity runs through the wire and creates a magnetic field around it. The pendulum swings in a different direction perpendicular to the horseshoe magnet's field and to the movement of the current. If we reverse the direction of the current, the magnetic field it generates will turn in the opposite direction, causing, in turn, the pendulum to swing in the opposite direction. Flipping the horseshoe magnet around to reverse the magnetic field around the pendulum will also cause the wire to swing in the opposite direction. The Lorentz force is what makes our electric motors work. Without this force, our modern world would be quite different.